Hello, I'm Tom Shapland, the CEO and co-founder of Tule. This is the second video in our series about the science of FieldStat. FieldStat is the evapotranspiration-based method for measuring the plant water stress. In this video, we're going to talk about how we measure the crop coefficient and at what point in the season FieldStat begins. Let's start by discussing what influences the actual evapotranspiration, or the plant water use. Plant water use is influenced by the weather, the size of the plants, and the water stress of the plants. In the ET paradigm, this is written as an equation that says the actual evapotranspiration is equal to the influence of the weather times the canopy size times the water stress. The influence of the weather is known as the reference ET. Reference ET is the amount of water a well-watered lawn would use given the current weather conditions. The influence of the canopy size is known as the crop coefficient. The crop coefficient tells us this is the size of the plants in this field compared to a lawn. The influence of the water stress is known as the stress coefficient, or FieldStat. To measure the crop coefficient in a field, we use the same method that researchers use. The starting point for understanding how researchers and Tule measure the crop coefficient is to recognize that in the beginning part of the season, the water stress is negligible. So we can assume that the water stress term is 1. If the water stress term is 1, we can drop it from the equation. And we now have an equation that says the influence of the weather times the influence of the canopy size is equal to the actual evapotranspiration, assuming there isn't any water stress. We can rearrange this equation by dividing both sides of the equation by the influence of the weather. In other words, dividing both sides of the equation by the influence of the reference ET. And we now have a new equation that says the crop coefficient is equal to the actual evapotranspiration in that field divided by the reference evapotranspiration. In other words, the size of the plants from a water use perspective, that's what the crop coefficient is, the size of the plants from a water use perspective is equal to the actual water use of the field compared to the water use of a lawn. This is an example of how we measure the crop coefficient in a field. This is the PRI chart from the Tule web app. The PRI chart is the actual water use divided by the reference ET, the actual ET divided by the reference ET. In the beginning of the season, there's an active cover crop, so you can see that the actual water use compared to the reference ET is close to 1. That is, this field uses about as much water as a lawn. Around mid-April, the grower discs the cover crop, so we can see that the water use of the field compared to a lawn decreases substantially, down to about 50%. Over time, the vine canopy grows in, and we can see that vine canopy grow in. And as that vine canopy grows in, it uses more water compared to a lawn. And then eventually, the canopy growth stops. It peaks. And when that canopy growth peaks, we now have our crop coefficient value. When that canopy growth is stable and the canopy is no longer growing, we have the crop coefficient. When we have the crop coefficient for the field, we can now go back to the FieldStat equation, which I described in the previous video, and we can plug that crop coefficient value into the denominator in the FieldStat equation. We can now tell growers the water stress of the field is equal to the actual water use compared to the reference ET times the crop coefficient of the field. We can't provide FieldStat until we have a stable crop coefficient value, until the canopy has stopped growing. And now you know why. Thank you for joining me.